Okay, so now we're going to use those same properties we just talked about to expand our logarithmic expression. So when we expand it, I want you to think about we're making it bigger, right? We're going to make it longer. That's what expand means. So we're going to add logs. Okay, that's not really very mathy, but that's what we're going to be doing is adding logs. So if we have log of y over x to the 9th, remember that when we don't have a base there, we know that it's base 10, right? And the first thing I notice is that I'm working with division. And so division is matched with subtraction, right? So I can rewrite this as log y minus log x to the 9th. Okay? Notice that the instructions say that we should not have any exponents. So the next thing I have to do is take care of that exponent. And remember that exponents match with multiplication. So my answer here is log of y minus 9 log x. We're making it longer. We're adding in the logs. Okay? On the next one, I want you to notice that the power is only for the x, right? That's x to the 4th. Okay, so we just want to remember that. And that's multiplication in there, right? And multiplication is separated with addition, right? We talked about our name before. Nothing, add, subtract, multiply, divide, exponent. So we're either going up or down depending on what we're doing, right? And with this, since we are expanding, we are going up. So looking here, we have multiplication, which expands with addition. So that's log of y plus the log of x to the 4th. And then again, we have a power, and we want to get rid of that, so he's just going to come out front here. And we will have the log of y plus 4 log x. The last one, again, we have division, right? We have division here, which separates or expands with division. Subtraction, what's wrong with me? So I'm going to have log x to the 5th minus the log of y. And we have that 5 out as a power, so he's going to come out front. And my answer is 5 log x minus the log of y. So now what we want to do is use those same rules to condense the logarithms. So we're going to write it as a single logarithm. So that means we're taking the logs out. So first, let's remember nothing, add, subtract, multiply, divide, exponent. And this time we want to go this way, right? Because we are condensing it, so we're taking out the logs, kind of. Okay, so the first thing we're going to look for is the exponents, right? So I see here I have a 4 and a 2, and so those guys are going to become powers. So I can rewrite this first as log base 3 of x minus 6 to the 4th minus log base 3 of x plus 5 squared. Now, I wouldn't be able to condense this at all if those logarithms did not have the same base, but you shouldn't have any where the bases are different. Nobody's trying to trick you, okay? And then what I see is I have subtraction, and subtraction condenses with division, right? So we are going to have log base 3 of x minus 6 to the 4th over x plus 5 squared. Okay, let's look at the next one. Again, I have a number out front here that's going to become a power, and a number out front here that's going to become a power. And remember that when you have a fractional power, that's a root, right? So the 1/2 power is equal to a square root. So we're going to pull those powers out first. So log base m of 5w plus 1 to the 7th plus log base m. I'm going to go ahead and make it the square root of w plus 8, right? Again, that 1/2 power is the same as the square root. And then we have addition, and addition is condensed with multiplication. So I'll have log base m of 5w plus 1 to the 7th times the square root of w plus 8. Okay, let's look at the next one. Now we have 3 terms, right? Those first two only had 2 terms. Now we have 3 terms, but we have the same thing, right? Now I have a 7, a 1/3, and a 3. And so those are all 3 going to become powers. Okay, and we're not going to worry about this subtraction sign because we're going to take care of that when we do the division, right? So we will rewrite this first with that power. So we'll have log base a of x to the 7th minus log base a of the cube root of z. Right? 1/3 is the cube root plus log base a of y cubed. Okay? So now we're just going to go in order, and I'm going to take this subtraction sign first, and we condense subtraction with division, right? So I'm going to have log base a of x to the 7th x to the 7th over the cubed root of z plus log base a of y cubed. So I'm almost done. I want a single logarithm. Now I just have to deal with this addition sign, and we condense addition with multiplication. And so we're going to multiply the x to the 7th over the cubed root of z by y cubed. And when I multiply, I do top times top and bottom times bottom, right? So I'll have log base a of x to the 7th y cubed over the cubed root of z. Okay? All right, so here what's interesting is we have the 4 on the outside, and we also have, let's see, we have this guy and we have this, right? So let's kind of talk about a couple of things we can do here. We can go ahead and put the 4 here, right, if we want to, but I would probably wait on that, and let's look at why. So I'm going to deal with this 4 first. So I'm going to keep this 4 out front, and I'm going to say log base 2 of y minus log base 2 of w to the 4th. Then plus this 3 log base 2 of x, if I have room. Pretend. Okay? Now, so that I can get rid of those parentheses, or almost get rid of the parentheses, let's handle this subtraction sign. And so the subtraction, right, condenses to division. So I still have a 4 here. Log base 2 of y over w to the 4th plus log base 2 of x. Oh, 3, sorry. 3 log base 2 of x. Where'd the 2 go? Okay, so now, before we can condense the addition, let's handle these guys, which are our powers, right? But the whole thing is to the 4th power, right? This is log base 2 of y over w to the 4th, all to the 4th power, right? Because that 4 is in front of that whole thing, plus log base 2 of x cubed. So then, let's see, before we handle the addition, let's go ahead and deal with this exponent that has the parentheses, right? So then we would have log base 2 of y to the 4th over w to the 16th, right? Remember, when you raise a power to a power, you multiply. Plus log base 2 of x cubed. And now we can deal with this addition sign, and we condense addition with multiplication. So I'm going to have log base 2 of y to the 4th x cubed over w to the 16th. Okay, so they all really work very similarly. Looking here, we have some more expressions that look a little bit more complicated, but the work we're going to do is the same. So I have these guys out front, which are going to become powers, right? Multiplication becomes an exponent. And remember, we have a 1/4 power, and so that's going to become a 4th root. So that's the first thing I'll do, is rewrite this as log base b of 8w plus 1 to the 5th plus log base b of w plus 7, and we want that to be the 4th root. Now we can take care of this addition, and addition condenses with multiplication. So we'll have, wrong color. So we'll have log base b of 8w plus 1 to the 5th times the 4th root of w plus 7. Okay, last one. So here we have 3 terms again, and we have a couple of things happening. So the first thing I'm going to take care of is this exponent, which is going to come out and be a power, right? And we know that since that's a fraction, that's going to be a root. So we'll have log base 6 of the cube root of w plus, oh, I forgot to circle the 4 here. We have a 4 also that's going to become a power, right? So plus log base 6 of y to the 4th minus log base 6 of z. Then I'm going to take care of this addition, right? And we condense addition with multiplication. So I'm going to have log base 6 of the cubed root of w times y to the 4th minus log base 6 of z. Now I can take care of this subtraction, which is division, right? So I'll have log base 6 of the cubed root of w, y to the 4th over z. I will caution you about this, the cubed root of w, because the next thing is y to the 4th. So if you wanted to write that with the y to the 4th in front, you certainly could. The reason I suggest that is you want to be sure that when you enter your answer, you don't accidentally leave the y to the 4th under the root, right? It's got to go outside the root. So sometimes I think when you're typing it in, it's just easier if you have the root last. All right.